Welcome to the Vox Pathfinder 15-hour channel, and tonight we are helping to document this Dagnall transformer. It's a D4910, and it's supposed to be for 18 watt, dual EL84 output transformer. And we've got the scope tonight. We're going to use the variac, and we're going to inject a signal from the variac into the secondary side of the transformer, and then we're going to take readings from the primary side. And I have a little effect I'm going to show you that I did not realize in the past. So we're going to use several different voltages. We're going to start as close as to 1 volt, maybe go up to around 6 or 7 volts. And then we're going to calculate turns ratio and impedance ratios. Okay, so let me just put this up here so you can see the overall what I'm doing. Okay, I'm going to turn on the variac. I'm going to get a signal on here. Oh, before I do that, let me just reset our power. Okay, there we go. We got one signal. So what I'm going to do is I'm going to measure that voltage. That's 1/10 of a volt. We want to get a little higher. Okay, let's see what that is. Let's see, that's about 1.3. Okay, what's that one? This is 1.2. Let's see if I can get to like 1.1. If not, we'll just go with that. It's hard to get just about 1 volt off of a variac. We'll go with that, 1.3 volts. So now I'm going to measure the primary side voltage, and we have 56 point, call it 8. I just want to double check that we still got 1.3. 1.3, 56.8. So we're going to put that down, 56.8 divided by 1.3 to get the turns ratio. So it's going to equal roughly 43.69, just in the field of view. Then we're going to square it to get the impedance ratio. And then that's the impedance ratio. That's for this transformer. But I want to do something a little different. We're going to go back to 1 volt peak to peak. Of course, sometimes my 1 second. Let me just stabilize that signal. All right. Let's see what this voltage is. It's pretty high. Let's go a little lower than that. That's how I want to end up. I want to end up on a voltage like that. All right. Go back to this. Let's turn this down a little bit. Right about there. Let's see what that voltage is. Yeah, I'll go with that. 2.6 volts. Let's just remeasure that. Okay, now let's get a primary reading. This is 99 volts. Let's just double check that. 2.6. Close enough. So we're going to take clear 99 divide by 2.6 equals 38.077. We will square that. And look, the impedance ratio has already dropped from 1900 to 1450 approximately. Okay, so let's turn up the voltage a little more. See what that reading is. 3.2. Let's go. Okay, let's just turn it up. What's that? Let's just double check. We don't want to go too close to 2.6. Let's get it up a little higher. Okay, what's that reading going to look like? 5 volts. We'll go with that. Okay, so let's get a reading off the primary side. 173.5. Let's just double check. Yeah. Okay, let's crunch those numbers. 173.5 divided by 5 equals a turns ratio of 34.7. Of course, you know, physically the turns ratio can't change. That's set by how many coils are around the transformer. But it seems to change when you take different measurements at different voltages. So we're going to square that. And now we have an impedance ratio of 1200 ohms approximately. Okay, let's bump this up a little more. All right. You can see that on the screen. Okay, we got 6.4 volts. And I'm going to have to switch this over to the higher scale. This is 219 volts. So let's just double check the injected voltage. Still 6.4. Double check this reading. Still 219. Let's crunch those numbers. 219 divided by 6.4 equals, see, it's not as big a change here, 21875, whatever. And then we're going to square that for the impedance ratio. Now we have 1100 and 70 ohms or 71 ohms.